Recording and no copyright strikes. Alrighty, so today we are going to wrap up the configuration management aspect of our software development process. So hopefully last time everything made sense. So we were basically kind of covering things in terms of like a more subversion. So I'm getting rid of my little tea bag there, so I don't spill tea or have my little cute tea guy on stream. Um, but we looked at the classical view last time, and that was the standard for pretty much ever. So if you kind of missed what we were talking about, again, we're going over the different versioning schemes and how to do baselines and tags and all of that fun stuff. And think of tools like Subversion, Perforce, I think, is another one which was commonly used in this area. And what we're going to do today is we're going to talk a little bit more about Git. And I know that you have homework to do in Git. I was kind of intentionally giving you the hands-on stuff early, and now we're going to talk about a little bit of the theory behind it, I suppose. And if you're not aware, we have GitLab Part 2 here in your software engineering folder, due coming up here soon, so the 29th. So don't forget about that. If you have any questions, again, please feel free to let me know. I know some of you have already started asking me problems. So again, if you have issues, usually it's very helpful if you also include the errors in your email so that I can try to figure out what your problems are. Because unfortunately, I'm not necessarily looking over your shoulder and seeing what you're doing wrong. But so far, everybody seems to be doing relatively okay with it. Anybody have any questions on what I'm looking for homework-wise? Is everything making sense? And hopefully we have clarity in the assignment. But I hate that I have to go to Twitch to get to my better TTV emotes. There's probably a Streamlabs extension that I'm not aware of now. But no. Alrighty, so radio silence, I assume we're all okay with this. So yeah, just make sure y'all get that in. And I will come back to this as well. So we kind of ended here. Awesome. Thanks for the thumbs up. Lets me know that there are actually people out there rather than 23 bots hanging out in stream. Nothing like talking to bots. All right, so we ended with development and release configuration management. And I left a couple of slides here for the end because I wanted to kind of go over a workflow. Did I do Monka S wrong? Yeah, I forgot the lowercase m. I don't even know if that went through on chat. All right, so we've been using, if left for all intents and purposes, like a subversion kind of workflow here. All right, so we have a project. That project has milestones. For this class, it's going to be obviously your homework assignments or midterm and then final presentations, things of that nature. In terms of an actual project, though, we care about successes. We care about meeting these milestones. That shows progress along the way. So call it a task, call it an issue, call it a a user story that you're checking off, whatever it is. You want to make sure all of these little artifacts are satisfied as you go along the way. So your basic workflow for a project, this will apply to any config management tool. You create your project. You go through all the rigmarole of finding a customer, defining requirements, going through all the steps of your process, right? So that is your project. You're going to create a series of tasks. Now these tasks are going to be baked into your configuration management tool, right? They're going to be called tasks or issues or something, and you're going to assign them to each check-in or commit that you do. And then completing those tasks shows progress on the project. Now, if you complete all your tasks, is your project done? I should probably be presenting, not showing you half of a screen here. Are we done when our tasks are checked off? No, 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 no. Why not? Everything's done, right? No. Hmm. Like that. Testing, testing, testing. Hey, great. Yay. Testing, maintenance. We have so much left over to do. We have delivery. We have everything in that cycle still, right? But we can have tasks for those too. You can have tasks and still have bugs, exactly. The interesting thing is that this config management tool is going to have tasks for each step of the process. So there is still a whole lot going on. We can have testing tasks, right? We can check in our unit test results and our integration test results and all of this fun stuff. You will have a project closeout meeting. There will be ways to check everything off and finalize everything. But yes, we always are going to have maintenance, right? Always have maintenance. So here is one slightly different view. So we've been kind of talking about things in terms of, release and development. We haven't really talked about change management too much. I've kind of alluded to it. So this is where it's kind of baked into our configuration management. So you're going to see these terms if you start looking at, software process blogs or books or anything like that. You'll see change management, you'll see configuration management. You'll think they're the same things. They are not the same things. So change management is a subset of config management effectively. You have to make a change of some kind. So let's say that you create a baseline, you create a tag, a release candidate, whatever it is. All right. You have to update it for some reason, whether it's your next sprint, your next release, customer requirement changed. You have a change that has to occur. All right. And we have a little flow chart here, not little, it's kind of big actually, where we have a process for the process. We get 30 layers deep into processes. It's processception. But why do we have to make this change? What type of change is it? Do we need people in charge of the change? Or is it like a simple developmental change where you give it to your team? Or do you need something a little bit higher up? So there are still going to be processes for how you do pretty much everything. And again, why do we have this? Is this just the business people getting their hands on software development? No, this is what we need for consistency, right? So if I have a major change where things really hit the fan, customers unhappy, we're probably going to need a lot more eyes on it or a lot more people fixing it or working on it. So there's a lot of things that can go into this. And then, of course, after you're done, have your review, close your change. And all this means is that you've gone through a change process to update the source code or update an artifact. And this all gets reflected throughout the project. Right? So an emergency change, what would that be? It'd be something like a recall, right? So think of the Toyota Prius case study we looked at, or any time you've ever had to go into the dealership for a software update on any of your car parts, right? We're going to need to change things on the client's end. That might be an emergency or significant. Minor standard changes, we already have those pre-approved. So it's toy car downstairs. So basically, that's pretty much the end of part one of config management. So process, process, process. Make sure that we have a tool to support that. And you can pick any number of these tools, right? Subversion, Perforce. I start bringing up Perforce because it completely slipped my mind when we were talking last time, but that's one of the other big tools that industry has liked to use in the past. So now we're going to get into Git. And today will be an exercise in seeing how many times I can say Git and get together and not cringe at myself. Before we get too deep into this, one thing I will mention, so there is this Git online book. So this is basically, it's a free, I'm not sure if it's open source or not, but git-scm.com/book, and basically you have everything you need to know about Git if you want to dive really deeply into it, right? So if you start searching for Git-related help topics, like you Google it or Bing it, if you're going for that sweet click revenue for yourself and coupons, if they still do that, you're probably going to get redirected here at some point, so I just figured I'd point it out. It's somewhat helpful. And yeah, anyway, we've got some demos today. We've got some chatter about Git. That's pretty much what we have for the rest of the time here. And again, if you are just joining now, the point was with the homework was to have some hands-on experience with Git before we started talking about the philosophical ideas of it. It was pretty much paradigm shifting in terms of source control and configuration management. So everything we've been talking about so far will apply to Git. However, the implementation is going to be slightly different, and the ideas are different, and it actually makes teamwork a lot easier, in my opinion. And I will say this as somebody who, for the longest time, resisted Git. I liked the idea. I was stuck in the dinosaur era. I really liked Subversion. I liked the older methods, and then I finally got on board with Git, and now quite happy with it. So, old people can change. And I say old, I'm not even 40 yet. Old to everybody else, I'm sure, on the internet. So we're going to talk about today look fairly similar to what we talked about before, right? We talked about repositories in kind of a light way. Basically, your config management tool was a repository. Tagging, we kind of talked about. Branching, we talked about. Merging, we talked about. There are some differences here, though, so you're not getting, the same talk as last time. So the interesting thing about Git is that it has become one of the more widely used source control code management tools, config management tools out there. There are nice public interfaces like GitHub. You can use Git to talk to sites like Bitbucket, although they also, I think, use Mercurial as well. You can run your own version of GitHub locally. You can run something called GitLab, which is a Ruby environment, and it takes a crap ton of resources to run. So don't throw it on a Raspberry Pi and think it's going to be happy. You can also run Git on the terminal. So Git was developed to be a command line tool. And there's lots of ways to run it if you're interested. Basically, you can run your own little homebrew version of GitHub if you want, was kind of the point. The thing that I found really interesting was that Git was actually created by the guy who created the Linux kernel, so Linus Torvalds. They needed a way to share source code for the operating system, and Subversion wasn't cutting it. So, hey, let's create our own revision control system. Why not? And it's actually been very, very positive in what it does. GitHub comes along in 2008, and you're all aware of GitHub at this point, I hope. If you're not, look at the homework. Don't forget, it's due in 7 days. 7 days? 8 days. I'm getting lost in my timing here. So GitHub comes along, provides free and paid GitHub repo or Git repo hosting. Now it's pretty much free for everybody. So a couple years ago, dial back a little bit, you would only have like 2 or 3 personal repositories. There was so much you couldn't do unless you were an organization or an educational institution. Like you couldn't check in personal commercial projects for the longest time. They finally started opening things up, which makes sharing things a lot nicer. And the thing that I find really, really interesting is that all of this open source ideology, I guess free and open source, depending on what your stance is on that, it's owned by Microsoft now. So the thing that was happening behind the scenes that was, I thought, really interesting, GitHub was just bleeding money, and they were not going to last very long. So if Microsoft hadn't bailed them out, there'd probably be no GitHub as we know it today. So keep in mind, Microsoft owns it right now, but they're also open sourcing all of their tools, which I find kind of interesting. So that's kind of the state of things right now. We're using Git in class, obviously, because it's the new and exciting thing, and I find it very useful. There are other tools out there, and what we have here is a very blurry picture when it's blown up to full screen I'm seeing. This is this particular person's workflow for Git. You all have my personal workflow for Git. This one is a little bit more detailed. If you go to this blog, and again, this is from 2008, so it's dinosaur era for the internet. He links to somebody else's workflow for Git, which is quite different from his own, which I find kind of interesting. You think of source control, you think of consistency, you think of everybody doing the same steps. The interesting thing with Git is that everybody can do kind of their own process and it ends up in the same state. It's very flexible. Yep, everybody can hear you. Here's your wholesome meme for the day. Anyway, so here is a process for Git. So we have 4 databases here, 4 repositories. You have your local workspace. You have something called an index. We have not talked about the workspace or the index yet. You have a local repo and a remote repo. Hey, there you go. That kid's a little bit young. Mine's 1.5, so let's baby rage. I like that. Mine definitely has some rage today. So yeah, your workspace is the folder that you're working in locally. You also have an index. You have a local repository. These 3 databases here are on your computer, and I'm calling them databases. They're basically just folders with file stores. I mean, it's nothing super complicated. All right. Remote repo in yellow here, this is what is somewhere else. This is your GitHub repository. This is your GitLab. If you're running a Git server somewhere, depending on your setup, this can all be on one machine. It just depends on what you want to do. The point is, in the keyword, the preview keyword is the notion of Git is distributed repositories. The traditional side is non-distributed, and being distributed, you have a lot more flexibility. So what is the workflow here? So let's say that I'm working on something locally. I'm going to do a commit to my repository. So I have my files. I'm going to add everything that I'm working on and add -u, like you all have been doing add dot. That just adds pretty much everything that's ready to go. Add -u only does tracked files. It's like if you add a new file, this -u won't catch it. The dot will. You can do add -a to stage everything. I mean, for us, git add dot has been fine so far. But git add -u, git commit, and then your repository gets updated. Push then goes to the remote. So this is similar to what I showed you all. Instead of -u, it's dot. Commit, commit -m, commit message, right? So we all know this. Here we have a git pull or rebase. So git pull is just pulling down all the changes. Rebasing is where you're bringing your repository back into a normal state, basically. Git fetch, we're going to be pulling things down from a branch, or a checkout. We're basically reverting to some other commit. So we haven't really talked about that. I'll show you some examples of that in a little bit. Diff, I alluded to, this is where you're looking at differences between 2 files, between 2 folders, something of that nature. And I wonder if I have it, sorry, let me do a quick little diversion here. Do I have diff merge on here? Super, super helpful tool if you're on Windows. I don't know if it's available on Linux, but diff merge. I've used this thing for years and years and years. Just gonna pull this down to the side just to get it installed while we're talking, because I completely forgot about it, but it does really, really nice folder differencing. Keep, install. Please don't be the virus-ridden thing. Live installs, love it. This is exactly what I had in mind when I was planning out class for today. All right, so we have all of these different strategies here. Hopefully none of this is new to you. Just waiting for the installer to go, and I want to show you this. Awesome. All right, so diff merge. Find a tool that you like, but I like this one. Left folder to compare. Let's look at GV, or nope, I want my research, roguelikes. Frederick's term project. All right, select. Right folder. I want my Frederick's SE term project. So I have 2 folders that I'm going to compare here. There's differences. Where is my folders? Hey, There we go. All right, so I have not enough stuff in here to make it useful. Basically, let me I'll come back to this one. I guess I thought I had more stuff in there. Let's do this. Copy, readme, Fredericks, SC term project. Bim, Fredericks. Sorry, here. Fredericks, SC, readme. Oops. This is when demos go bad. This is a difference. OMG. Clear. All right. Refresh. Hey, here we have a difference. So now I see, hey, there's my diff. So this is the notion of a diff in a little graphical tool. Again, use whatever virus. Ooh, no. The thing that I like about this tool, and again, pick one that works for you. There's probably a better one out there now. This does really nice folder comparisons. So I see there's some differences. I see definite difference. And then I can basically move things over. So like if I want to merge something from the left to the right, now it's back in the normal state. So if anybody has any cool, nifty tools for doing file comparison, folder comparison, I'd love to see what the new things are out there. That's a nice little free tool that I've used, honestly, since probably 2007, because it's worked well. But it's not very good with binary comparison, like you can't do PDF compare or Word compare or anything like that. All right, so that's our standard-ish. Again, what's the name of that tool? I'll put it down here, diff merge. And it's one of those tools that are like up on SourceForge where you have to make sure you click the right download button. Notepad++. I haven't really used Notepad++ myself too much. I'll have to look into that. Again, I'm more of a Vim person. That's personal preference. But yeah, again, use whatever tool is going to work out for you. The only thing that you really care about is checking differences. And this is going to be helpful if you have like a merge conflict, right? You have changes that you've made locally, your remote repository has changes. How do you merge your code in an intelligent way? So that one works for me. All right, so I've been talking about repositories quite a bit, and what are they? So they're a set of commit objects. All right, so these objects are basically packages of changed source code, and you lump everything that you've changed together. Right? There's also a ID for each commit object, so it's a SHA-256 hex string. We also have references to commit objects, so your heads. We'll show you what that looks like here momentarily. And these repos are actually stored in the .git subdirectory. So there is a hidden folder in every Git repository. If you're in Windows, you have to untick the show or tick the show hidden folders checkbox in File Explorer. If you're in the terminal, you can do ls-a, or I like ls-la because that gives you the long listing. But the A is going to show you hidden files here. So here we see .git, right? So that wasn't there before. If I do ls, there's no .git. ls-a, oh, there's .git. It's right there. What's inside of it? Well, it's everything we need to have a local database for a repository. So what's the head? What are our branches? What objects do we have? What references do we have? And the long story short, do not modify anything in here by hand unless you really know what you're doing. This is effectively a database with a very structured environment. So avoid touching any of the files in here. It's hidden basically to make sure that nobody plays with it. But that's where everything is on your computer. So you have a local repository. So your .git folder, that is your local repository on your computer. If you delete the .git folder, you have no more repository. You have a folder full of files that are no longer tracked. All right. And there's no central repository. Basically, you have a remote or a series of remotes. But the notion here is that we're distributed. So I love this figure because this actually gives you an idea of the differences between the standard model and the Git model. So we're going to pick on Subversion here. Pretty much all of your traditional um, revision control systems are going to look similar. So you have a central repository somewhere, right? This is your Subversion server, your Perforce server. What are some of the other ones? Drawing a blank. Whatever your source control system is, you have a database somewhere that you're going to connect to remotely, right? You log into the tool, maybe you're doing it through the command line, but you can do your branching, your log, check your logs, do your merges, push your commits up to it, pull down updates, but basically you're talking to a server somewhere, right? Your IT might be in charge of it, or your DevOps team might be in charge of it. What you're going to do, this workflow, is that I'm going to create a local sandbox in my computer, right? I'm going to make a folder. I'm going to say, pull down the latest version of all of my files onto my computer. And what happens here is that I get a working copy and I do my updates locally. And when I'm ready to make a change, I make sure that all the locks are in place that we talked about. I make sure that I have updating rights and all of that. And then I push my changes to the Subversion server, for instance, right? So this only works when we have a network connection, when we have the correct locks and everything, and basically everything is server based here. So, and the thing we talked about last time, where I was asking you why do we lock things? Well, consider that you have 500 employees with a working copy of the same project, all trying to update login.php or trying to update anything in this server at the same time, right? I have to wait until the locks are released. Mildly annoying. However, in the Git model, we don't have this centralized notion. So we can have all of these tasks which are done on the server side are pushed to your side, right? So whenever you are working in the Git model, you're pulling down the entire repository to your machine. Okay, so we haven't talked about blame. This is basically where you can assign blame to somebody. It's kind of fun. But I'm going to have my working copy in my local computer. I'm also going to have that database in my computer. So all of the administrative tasks are pushed down to me. And then when I push everything back up, the entire state of the repository gets updated. It takes a little bit of um, bashing your head against the wall, for lack of a better term, to kind of understand this idea that I'm pulling down the entire thing and then pushing it back up. Obviously, you're only pushing what has changed, but this allows people to work in parallel a lot easier, right? And then the Git model also allows pretty easy merging. So if two of you are working on the same file, um, and one of you makes a change and the other one makes a change and pushes it like 5 minutes later, you'll get a notification that things have changed. You're in a merge conflict, and you just have to figure out how to integrate your code a little bit easier. But this actually tends to speed things up and work a lot more intelligently in a way. Honestly, I like this model. It took a while for me to kind of buy into it, but I'm definitely liking it. But if you take anything away from this figure, all of these bubbles up here have been moved down here. So that's the too long didn't listen to the guy on the screen. So it's an interesting model for source control. So to circle back to commit objects a little bit. So when you do a git commit -m, right? So you're getting a set of files, references to the parents. I mentioned this earlier, and then also a SHA identifier. So this is a cybersecurity term where basically you're getting a randomly generated string of hex numbers following this particular protocol. Again, all this is a package of files with particular states, particular versions. Interestingly, if I have two commits that are exactly the same, so the files are the same, the parents are the same, the branch scheme is the same, the ID is actually going to be the same. So we have this notion that the identifier is basically going to be generated based on the state of the project. So again, that's what a commit object is. All right, so here we have a view of what these objects look like in your repos, local or remote. You're going to have a very similar view here. Should look pretty similar. When we talked about branching in the standard model, right? We had file, file, branch, branch, more files, and then maybe our branch ends, maybe it gets merged back down, just depends what's going on here. Here, again, we have a commit object, so this is going to be a package of files. So what is the state of the project at this commit? And there'd be a really long ID attached to this. So question to you all, how do you figure out what commit objects are what if you don't actually know their ID? So maybe preface this by how do we figure out, how do we access another object? How do we access a commit object? Anybody have any ideas? Got my lovely iTwitch Louise GIF here. Kind of looks like it could be a logo for Git. Use the Git log. Hey, there we go. Exactly. That's one way to do it. Git log. So here we have a text version of the entire history of your project. All right, so here you have your very long string of the ID. This is the latest commit. Is this the head, which we'll talk about in a bit? What are the branches it's on? Who made the commit? When did it happen? What is other information related to that particular project? So again, this is the terminal way. You can also go into whatever your remote repository tool is. So the nice thing about GitHub is that you have a nice kind of historical view in a web-based format. So if you look at your project, so I got my team Professorson repo here. Not necessarily obvious, but all of these are links. So if I just click 14, let me zoom in a bit there. Maybe zoom out so that commits is there. 14 commits. So here you have basically a nice, pretty webified view of the Git log. A nice, easy way to copy and paste the identifier if you want. You can even look at what the state of the repo was at this point in time. Can you explain what command you used to get into your team project repo? So are you talking about getting in here right now? I guess maybe I'm not sure what your question is. Sorry, Kyle. Yeah, so let me maybe start from scratch here if that would be helpful. So again, I'm using the Ubuntu terminal. Feel free to use whatever your preference is. I'm in my home directory here. So if I do pwd, I'm in home/Eric. I have an alias to get to my documents folder, which is in here. So when you did the git log, how does it know which repo? Oh, okay, yeah, I see what you're saying. So I am in the folder for my term project. So this is what I did git clone for. So like I did git clone github.com Frederick's CS350 term project. And then once I'm inside this folder, I can do git log. Right. So I actually have an example that I can do as well. So I've been looking at some various roguelikes. I saw there's a Godot procedural generation GitHub repo for like base starter projects using Godot. I could do git log in here, and then here is all of the information for a different project. So the git log is only showing a log for local changes. So no, this is anything that the repo has. So This is a Git repository for another project, so I just went to a different folder, which is a Git folder, and I did git log here. So here's all the changes that have been pushed from the end of time. So again, this is a local repository. I have everything from the remote on my computer. If that makes sense. And that's the distributed thing, where if I had a subversion or something else like that, I'd have to query the server to get this information. Here it's all on my computer. Interesting thing that might be worth noting if you do a git log and it's tied to an email address. I have this person's looks like personal email address, so be careful of what you put into websites, it seems. Um, so yeah, that's kind of the notion here. Fredericks, yes. That makes sense though? Git log. I've got a bunch of changes because I was doing some demos last night to make sure that I had the commands correct for you all. Yes, thank you. Okay, good. Again, if you have any questions at all, anybody feel free to chime in. I'm more than happy to make sure you understand what's going on. All right, and if you end up screwing up your local repo, it's honestly part of the learning process for any source control. Just delete the folder and clone it down again and start over. And make sure you copy any changes you made, obviously. But you should see some of the things I did in my production repository at my old job. I got some people unhappy with me at one point in time. All right, it's a learning thing. It's all right. Okay, so git log is how we figure out which object is what, and that's why it's important to say what the commit is. Story time. We only have 10 minutes left. Basically, as a new developer, I made some mistakes in our version of Subversion, and I may have overwritten an entire development branch by accident. Fortunately, it's possible to revert. That's why you have backups of your databases for um, your source control, your configuration tool. Be careful when you check things in. Make sure you understand all the commands that you need. But anyway, so in Git you have this notion of a head. So when you looked at the Git log, you may have noticed head here. Basically, this is what the current um, for like the head of the project. So what is the version that everybody's going to check out when they clone it down or they pull, basically. So typically it's whatever the latest commit is. But there's nothing stopping you from putting the head at like commit object 2 if you need to revert or if you need to go back or anything like that. So it's basically just a reference. It's kind of treated like a branch, honestly, in a way, in terms of Git. But you're always going to have a head pointing to some commit object. And I mentioned last time that Git, and this is more for your own knowledge, the master is basically what the main branch is, the master branch. They're renaming this to main. So just be aware that the terminology is changing in Git. So probably, I think within the year, this change is happening. So I asked you, how do you reference a specific commit object? So once you do the git log, you can get all the information about all your commits, right? You don't necessarily have to type in the whole ID. It's helpful, but usually Git can figure out what that is. You can also check out the head or the master branch and the main branch now, or a named tag or anything like that. So for instance, let me go here. I should also mention too, when you do git log, if you have a long log and you're in the terminal, you can just hit Q to exit out. So I just hit the Q key. Let's say I want to check out an older version. So I have all these commits. Right now, I'm at the top of the project, but I want to look back. So what do we have here? Let's go back in history. Say I want to go back to when I updated this README. I want to be lazy and not type in this whole thing, so I'm just going to pick the first few letters that seem unique. So what was that? ED21. So git checkout ED21. I think that was right. No? Did I do that wrong? Checkout 664F. There we go. I just picked a different one. I must have typed it in wrong. So I did get checkout 664F just based on this commit ID. So now, if I do get log, my head is up here still, but where are you at? Where's the head there? Oh, the head is up here now. So I'm in what is known as a detached head state. And all this means is that my Git is looking at a commit that is not the very head of the project. So if I go to 350, I don't want to go into the source tree. I just want to go to the project. So right here is basically where my head is. Oh, I haven't pushed it. That's why it doesn't show anything. Okay. But if I want to go back now, I have to basically, I know I'm presenting. If I do, sorry, getting lost here in my commands I need to do. Get status, that's what I wanted. Head detached. So I'm looking at an older version. If I just do get checkout master, for instance, now I'm up to date again. ED21, yeah, thank you. It's very easy to fat finger keys when you're doing a live presentation, right? So now if I do get status again, branch is up to date, so nothing to commit. All I'm doing is moving what the working version is around. So this would be the same thing as going into something like, again, Subversion, right-clicking on an older version and saying checkout. Same thing here, basically. You could reference it by tag name. You could reference it by anything that will uniquely identify it. I could have just copy and pasted the whole thing, but Git will attempt to figure out which commit ID you're looking for, as long as it's unique. All right, so we talked about branching last time. Why would you branch? Exact same reasons here. Work on features, work on things in parallel. Um, any reason you could have to work basically, with other people on the same main area and then work on something separate or something specific. Feature, product line, whatever you want to call it. Usually there's a good reason why you would branch. Maybe you have a base repository that you have the production side, and then you have a developmental branch for your next version. Then when you're done, you merge it back down. All right. So branching in Git is actually pretty straightforward, honestly. I've got a demo for you here in a moment, but just to kind of show you how this looks, you're basically considering heads to be pretty similar to a branch. And this idea is a little bit different because you can still create separate branches on your tree. But if you move the head around, you're almost, in theory, branching as well, if that kind of makes sense. So let's say that I have my head is here on commit C, and then I make a fix on B. I can actually move the head back to B, and then I'm almost in like a separate branch, basically. So we also can create a branch with a view that kind of looks like this. So again, the difference here is that we had one main line and we moved our head around to go back to B. We can also be at B. We can be at commit object B, check something in or commit something here, and then create a new branch. So our main line here is still ABC, but we have moved our head over to D, and this is our new main line, basically. However, your master slash main, depending on when you're looking at Git, if you're 5 years in the future, this will be now main. Ideally, that should be your stable state, but there's nothing stopping you from moving your head to another branch and using that. So it's up to what you want to do here. So quick little demo. So right now I should be at the main. Yep. So let's go ahead and do this. Let's check out, what was the last one? 664F. Cool. I shouldn't have cleared this out too quickly because this information is useful. Git is actually telling you what's going on. So you're in a detached head state. Makes sense. Look around, make experimental changes and commit them, and discard anything you make without impacting or performing or any other branches. However, if you want to branch, do this. So kind of helpful information if you want to start doing branching. All right, so I have checked out this commit. Now let's create a branch. Git checkout -b test. The -b just creates the branch if it doesn't exist. I have a new branch. Cool. Git status. I am on branch test. So again, terminal based might not make sense visually yet, but I was at the main. I pulled down an older version. I created a branch from that version. Okay. So now let's update README. This is my test branch. How cool. 3 minutes till class is done. Let's see if he screws up his commands and point and laugh at him. It's usually how demos go for me. Alrighty, so I have my README. I need to now add it. So let's just add it manually. Could have done git add dot or git add -u. It's all the same. Git commit -m. Added testing message. Yippee. Getting playful. All right. Git push. Oh, interesting. I forget about this. So right now, I can't just do a straight up push because my branch has no upstream branch. Basically, what this means is that there is no branch up on the remote. I don't know why I inflected it that way. Up on the remote that, basically it doesn't know what test is. So Git will tell you the commands to type in. Git push set upstream origin test. All that's doing is saying make a branch off of the origin called test. Go ahead and do that. New branch. Git status. Nothing to commit. Working tree clean. Cool beans. So if I now go over to GitHub and I go back to my project, interesting, I have some changes here. Again, I updated the remote. Test had recent pushes less than a minute ago. Okay, what you see though is this little drop down. Let me zoom in for maximum effect. This is your list of branches. So I've got master and test. You actually see 2 branches here. If I flop over to test, there's my change. Okay, so I have a branch from my project. If I go back to master, we don't actually see my updates there. Did you just perform a git cancel? Oh, no, I didn't. So yeah, sorry. Control C. So basically I started typing something and I hit cancel. Sorry. Sorry about that. The last thing I actually did was git status. Yep, should be very careful about the commands I type in. Alrighty. So now, clear this out. Git checkout master. Okay. Git fetch. And if I look at README, I don't see those changes. So what I've done here is a handful of commands quickly. Git checkout master. So I was on my branch. Now I pulled down master. And I did a git fetch just to make sure that all the changes were on my local machine. And now I see that on my master branch, those changes are not there. Okay. Does anybody have any questions from today? Is everything making sense? Basically, you should still, everything for the homework you should still be able to do. We're just kind of doing a little deeper dive into Git. All good? Everything is making sense. Good, good, good. Again, Please feel free to stop me if it doesn't. It's hard to see if anybody's eyes are glazed over in class or not from this view. Anyway, thank you all, and Friday we'll wrap this up and start talking about requirements. It will be fun on the bun. Goodbye, everybody. End stream. Ah, there we go.